Good morning, Mr. Turton. Could you please introduce the student to the lab we're doing today?
Good morning, students. Today, we are going to be doing some demonstrations on how polarizing filters work. This is a polarizing filter. It is a polyvinyl alcohol plastic sheet with iodine doping. We're going to show you how light can be polarized by using these sheets today. First, we are going to use a slinky to demonstrate how light travels. As you can see, when Mr. Tran applies a force to the slinky, it travels as a wave back and forth horizontally. Next, we are going to use a wave generator and string to also help demonstrate how light travels. As you see from the movements of the string, the waves of light can also travel in vertical and diagonal directions as well. Light is a transverse wave that oscillates on all planes, and a polarizing filter is a bunch of slits side by side, imagine like a picket fence, that only lets light that is oscillating in that direction come through.
Now I hold this filter sheet upright in front of the computer screen. I can see the view from the computer screen. Then I rotate the filter sheet 90 degrees. Now I don't see much of the screen. Now I hold the filter sheet horizontally in front of the cell phone. I see the cell phone screen. And when I rotate 90 degree angle, now I see the cell phone screen is getting dimmer. Again, I hold the filter sheet horizontally in front of a LabQuest 2 screen. I see the screen. I rotate 90 degree angle. Now the screen of the LabQuest 2 is getting dimmer.
Next demonstration, Mr. Tran will find a flare spot on the floor tiles. He looks through the polarizing filter and then rotates it 90 degrees. After rotating it 90 degrees, he can no longer see the flare spot on the tile. Mr. Tran can see it, but it was very difficult for us to film it, so we are just describing it to you. Now we are going to show you one last demonstration before we move on. Here we hold the polarizing filter in front of an incandescent light bulb, and you can see when we rotate it 90 degrees that the light does not change. The polarizing filter does not have any impact on the light shining through. All lights are polarized differently by the polarizing filter. Some lights totally disappear, some only get dimmer, and some are unaffected. In the next set of demonstrations, we're going to use two polarizing filters.
Now I hold one polarizing sheet in front of the computer screen. I see the computer screen. Next, I place the second polarizing sheet in front of the first one. I still see the screen. Then I try to rotate the second sheet in front. What happened is the screen light is getting blocked.
If the polarizers are at right angles to each other, all the light is blocked, as you can see here, because one only lets horizontal oscillating light through, while the other only lets vertically oscillating light through. Therefore, the light sources from part 1, where all the light was blocked, must have already been polarized to begin with. And when their light was totally gone, the polarizer must have been at the right angle to the direction the light was oscillating. In this demo, we're going to use 3 separate pieces of polarizing filter. First, hold 2 pieces of polarizing paper perpendicular to each other in front of the projector screen. As you can see, all the light is blocked. Next, take the third, smaller piece of polarizing paper and place it in front of the 2. You can see nothing. Behind, again, you can see nothing. Finally, we put it in between the 2 other pieces of polarizing filter. At first, you can see nothing, but when we rotate it, it has become visible. We've reached the end of this video. We hope the demos from today have helped you better understand polarization. If you have any suggestions for how we can make these videos better, please email Ms. Holman or Mr. Moens. Thank you very much. Bye-bye.